Pip install glom installs the Python package glom using a Python environment such as a Jupyter notebook or through a command line. Glim is a Python library that allows the extraction of nested data from nested objects, such as dictionaries and lists. The in the command tells the environment to execute the command as a system command, since pip is a machine executable and not a Python function. By executing this command, the pip package manager is invoked to fetch and install the glom library from the Python package index py for use in Python. During this process, you will need to locate the latest version of glom, resolve its dependencies if any, and download the required files and install them. It installs a specific version 4.3 of the transformers library with its optional torch dependencies. With the transformers library by Hugging Face, you can perform tasks such as text classification, information extraction, and question answering with pre-trained models. After transformers, the torch indicates that the installation should also include the ptorch dependency, which is a deep learning framework commonly used with the transformers library. The syntax at the beginning of the command does not allow lines of text in Python notebooks or Jupyter notebooks to be interpreted as shell commands but rather as Python code. Python's package manager, pip, facilitates software package installation and management by facilitating the use of command line switches. You bet, based on the code, it appears to be part of a Python script intended to interact with Twitter's API. By utilizing the Tweety library, the script can automatically access Twitter capabilities, such as posting tweets, reading tweets, following other users, etc. This library stores and manipulates JSON data, that is, the format that Twitter API uses. Using these libraries, the script can authenticate with Twitter, retrieve data, and extract and manipulate information from the returned JSON data. Without additional code, it is unclear what specific actions this script can perform. With the glom module in Python, you can extract data from complex structures like nested dictionaries, lists, and combinations thereof. You have provided a code snippet only importing the glom function, which is the first step before importing it. In general, after importing, one would use the glom function to specify a target data structure and a specification often called a spec describing what data is to be extracted or transformed. Glom traverses the target according to the specification and returns the result. Code snippets you've uploaded don't actually call the GROM function. Therefore no data operations are being performed. The function is only imported so that it can be used later in the code. You have provided an import statement in Python that brings in external functionality provided by NumPys. For numerical computations, Python's NumPy library is very popular. The software supports multidimensional arrays and matrices, as well as a wide range of mathematical functions. The codemer loads all NumPy library features into the current code by writing import numpy as nip. The as8 part of the statement gives a shorter alias to the library. So instead of writing numpy function name every time they want to use a function from NumPy, the codemer can write nip function name, which is more convenient. It consists of one line of Python that imports the pandas library and assigns it the shorthand alias dt. The pandas data manipulation library provides data structures and functions to manipulate structured data, especially tabular data like spreadsheets and CSV files. Typically, this line of code is at the beginning of a Python script to enable pandas features throughout the rest of the script. As soon as this import statement is executed, the user can use pt to access all of pandas function and class properties. Import math includes the math module, which provides access to countless mathematical functions and constants. As part of the Python standard library, this module doesn't need to be installed separately. This allows the code to access constants like math, pi, which is used to find the value of pi, and functions like math, sit, which calculates the square root. Incorporating this line allows the codemer to perform complex mathematical operations without having to implement them from scratch. Most likely the code snippet was an import statement from Python's datetime module. It imports both the datetime and time delta classes. In Python, dates and times are created and manipulated using the datetime class. Date or time instances can be created, and functions are available for parsing, formatting, and computing differences between dates. Time delta is a class that represents the difference between two dates or times as a duration. Using it, you can add or subtract a specified amount of time from a datetime object. For example, you can get the date in number of days from now, or calculate the difference between two datetime instances. The code sets up a Python environment for manipulations of date and time. Python code imported with Finance library. The Finance library is a popular free open source library for getting historical market data. By importing this library successfully, codemers can access functions and classes defined in it to retrieve stock prices, financial reports, company information, and other financial information. The code consists of only one line, which performs the import action. It does nothing else except makes Finance's functionality available. The code snippet you provided imports the Python library Beautiful Soup from a package called bs4. Beautiful Soup is a library that parses HTML and XML documents, typically used in web scraping or extracting data from websites, apart from enabling Beautiful Soup functionality to be used in other code that comes after this. This code does nothing on its own. A Beautiful Soup object can be created by importing a document as a parse tree, which can then be queried and manipulated to extract data from the web page the document represents, in a more human-friendly format. In addition to parsing various markup languages, it provides simple methods for codemers to navigate and search its resulting parse tree. This code snippet imports the request library, which is a Python module that is used for sending HTTP requests. You can use this library to communicate over the internet with a web API, request data from a web service, or send data to a server. The requests library allows developers to perform GET, POST, PUT, DLETA, among other actions, on curls and handle query parameters, form data, multipart files, and custom headers. Programmers prepare their code for web communication by importing request capabilities. You will be installing the eFinance library, which is a Python package that fetches financial market data from Yahoo Finance. As soon as the user runs this command, pip installer Python's package manager searches for the eFinance package in the Python package index py or other configured package repositories, downloads it, and installs it in the environment. In applications and codes, Yahoo Finance provides users with access to financial data, historical market data, and real-time prices using the eFinance library. This code section imports the regular expression matching module from Python's standard library, which provides regular expression matching operations. By using regular expressions, you can detect patterns in text, extract information, and replace parts of strings based on defined patterns. It is normally used in a codebase where text processing is necessary, and importing it allows the codemer to utilize their functions and classes to accomplish that task. In the snippet you have provided, however, no specific operations are performed with the module because you have only provided the import statement. This line imports all classes, functions, and variables from the newspaper module library into the current namespace. Using the newspaper module, a user does not need to prefix components with news. Since it is designed for extracting and parsing newspapers, user can directly call the functions and classes readily available in the newspaper library, including downloading articles, parsing their content, and analyzing them for details such as authors, publish dates, keywords, etc. This code will execute in the following steps. 1. In Python, the newspaper module is located and should be installed. The second, the module imports all the public attributes in the current namespace. The third step, thus, the module name prefix is not needed to refer to these attributes. Keep in mind that using from module import is generally discouraged as it can lead to a cluttered namespace and make the code less readable and more prone to errors due to name collisions. Importing the whole module with a prefix is often more convenient than importing only the specific components you need. From HTML import findDate is a Python statement that imports the findDate function from HTML. In this function, the publication date of a web page or HTML content is found and extracted. This code can then be used as an example for using the findDate function in your Python script to determine when a web page was published automatically without having to manually search for it. Several heuristics and patterns are likely used to discover the date in various possible formats and locations within the HTML file. Python's natural language toolkit and LTK library is used in the code snippet you provided to work with human language data text. In particular, the code imports the stop word set from an LTK's corpus module. It is a practice to filter out words that are not considered meaningful for understanding text data before processing it, such as the, is, and in, which often appear in texts but usually do not convey significant meanings. Using stop words, Python codes can access a precompiled list of these types of words in various languages, which can then be used to clean and prepare text data for further processing such as text analysis. Machine learning models for natural language processing, or text mining, data projects related to languages typically include this step as part of their proposing phase. It imports two components from the Transformers library, specifically designed for the PEGSUS pre-training with extracted gap sentences for abstractive summarization sequence-to-sequence model. This tokenizer process helps to convert inputted text into a format the model can understand. Pegasus for conditional generation is the machine learning model pre-trained for summarizing in a conditional generation scenario. Using tokenized inputs, it generates new text based on its training. A PEGSUS model is incorporated into the code to generate text, with a particular emphasis on summarization. A conditional generation model uses the tokenized text to create a summarized output. As the code you've provided indicates, it imports two specific classes from the Transformers library: Auto Tokenizer and Auto Model for sequence classification. This library offers pre-trained models that can be used for text classification and question answering, and is widely used for natural language processing tasks. This class creates tokenizer objects that transform text input into a format suitable for a transformer model. Depending on the tokenizer model, text can be tokenized into words, subwords, or characters. This class loads a pre-trained transformer model designed or fine-tuned for sequence classification tasks. Text sequences are classified as groups or categories by sequence classification. An application of this may be used for sentiment analysis, spam detection, or any other task requiring categorization of text. These classes are used to propose text data with a tokenizer and then feed that data into a sequence classification model. Typically, you would follow these steps. 1. Using the from pre-trained method. Initialize the tokenizer using the tokenizer associated with a particular pre-trained model. The second guideline: a tokenizer can be used to convert raw text into a form that can be understood by a model. The third point: pre-trained sequence classification model weights are loaded using the from pre-trained method. The model is then initialized with the weights of the pre-trained sequence classification model. The fourth point, calculate classification predictions using tokenized text. A state-of-the-art model of natural language understanding and classification is used in the initial setup, which forms the foundation of the task. Importing the pipeline function from the Transformers module is involved in this code line. Transformers offers a collection of state-of-the-art machine learning models for natural language processing (NLP). This function simplifies the process of implementing these models by abstracting away much of the complexity associated with implementing those models, so that tasks like text classification, question answering, and text generation can be performed quickly. Pipeline returns an object that is ready to work with input data when you call it. You specify the type of task you wish to perform, and it returns an object which is ready to work with the input data. Model tokenizer, which converts text into a format that the model can understand, and configuration options are all included in this object. This pipeline object allows you to use text data to process outputs, such as predictions for classification tasks or generated text for language generation. In this snippet of code, we are setting up an environment within a Jupyter Notebook or Python environment to display plots using matplotlib. It is initialized with the alias plot to import the matplotlib pplot module. Plots and charts can be created using the functions provided in this module. Second, the per matplotlib inline command tells Python to display matplotlib plots directly in the notebook, rather than in a new tab. With this command, any plot that is created with matplotlib will be displayed in the notebook itself whenever the plots show method is called or when a cell generates a plot. For data analysis and visualization, you will especially appreciate having quick access to your results inline. You provided 4 lines of code, each declaring a variable and assigning a string value to it. A web service API, such as the Twitter API, may use these variables for authentication purposes. A primary and secondary key, taken by the app or used to authenticate API calls. These credentials are named API key and API secret key. 2 variables, access token and access token secret, represent the application's ability to act on behalf of a particular user. A step-by-step explanation: the API key public identifier for the app is set. This is the secret key for the app and should be kept confidential. Access token grants permission to access user data to application. The access token secret is allocated, working together with the access token to authenticate requests. Together, these keys form the necessary credentials for OAuth authentication with an API, enabling the website to process requests on behalf of users while protecting their passwords. It uses Tweepy to authenticate with the Twitter API and is written for Python. Initially, Twitter provides an API key and API secret key when registering an application, thus providing an OAuth handler object. Authentication begins when this object is set up. The second line involves calling the setAccess token method on the OAuth handler object auth, passing in the access token and access token secret, tokens obtained from Twitter or user-specific, meaning actions can be performed on behalf of a particular Twitter user. The last step is to instantiate a Tweety API object with the complete authentication handler. In Python code, this API object allows your Python code to communicate with Twitter API, enabling it to send tweets, read timelines, and manage users. In other words, anything that the Twitter API allows and you have access to. It installs the newspaper3 Python library, which can be used to extract and curate articles from the web. Running this command instructs Python to download and install newspaper3 from the Python package index.py repository into the Python environment. The library provides features such as scraping news articles, extracting text, and performing natural language processing. A function called getTweets retrieves tweets related to financial tickers and organizes them into pandas data frames. There are 2 parameters to the function: a list of ticker symbols and how many tweets to retrieve per ticker count. Firstly, the data collected from tweets is stored in a data frame named tweets. Iterates over the given ticker symbols by using a search function. The Twitter API is called for each ticker symbol for which tweets matching that ticker symbol were requested, in English and up to a specified number. Using the search result, we create a new data frame. For each retrieved tweet, various details are extracted: the timestamp of the tweet, the text content title, the ticker symbol it relates to ticker, the tweet's ID, tweet ID, the user's ID who posted the tweet, user ID, the user's screen name, the user's follower count, followers, and the user's location. Data frame elements are exposed by applying a function to each of them, and nested information within tweet objects can be accessed by using the glom function. Extracted information is organized into a temporary data frame temp. Data frames are generated from this information and compiled for each ticker. A unique tweet data frame is created after all tickers have been processed. Finally, the populated tweets data frame contains all the desired information from the tweets about the given tickers. An arbitrary number of tweets related to a list of bank-related tickers or identifiers is collected by the code snippet. The code defines a list called ticker list, which initially contains strings representing the ticker symbols or names of different banks and bank indices. In this list are symbols of major Indian banks like NIFT, YBNK, SBI and State Bank of India, IDBI, XISBANK and others. After that, the variable count is set to 1000, indicating that 1000 tweets should be retrieved. Following that, the function getTweets is called with 2 arguments: ticker list and count. This function retrieves tweets based on bank tickers specified by the ticker list argument, and the count parameter specifies the number of tweets to retrieve. Following execution of the find Twitter functions, you should see 1000 tweets related to each of the financial entities listed in ticker list. Twitter tweets are stored in a variable called tweets. In this snippet, that part is not shown, but likely analyzes social media sentiment, market trends, or public perception regarding these financial entities. Apparently, the code you are referring to is a command typically found in a Python environment using the pandas library, which is widely used to manipulate data. Basically, it calls the head method for the variable tweets, which is accessible via the command tweets head. The variable is presumably a data frame, a labeled two-dimensional data structure that can hold various types of data. As a default, the head method returns the first 5 rows in a data frame of tweets, in addition to looking at the column names and what type of data is contained in the first few rows. This is often used to quickly see what the data looks like. Users of the code can specify the number of rows they want to see as an argument to the head method, like Twitter, Hatton for the first 10 tweets. First and last date is a function designed to process data frames containing a timestamp column. This function finds the earliest and latest dates or times in a column. The steps are as follows. 1. A data frame is a set of rows and columns of data organized by timestamp as one of the columns. That is the argument that the function takes. By measuring minimum values in the timestamp column, it finds the earliest date and time. It stores this value in a variable called first. This is achieved through NumPy, abbreviated as NIP, a library used in Python for numerical calculations. There are 3. This variable will store the value of the latest date or time corresponding to the timestamp column. 4. In addition, the function returns both the earliest first and the latest last dates or times found in the timestamp column. The function is essentially a simple tool for extracting the range of dates or times in a dataset. Code like this seems to be part of a larger code dealing with tweets. The function first and last date is called with the argument tweets, presumably a list of tweet objects. Within a collection, the function should return 2 values, the first tweet's date and the last tweet's date. After this is done, the first 2 and last 2 returned values are stored in variables first t and last t. Using these dates, the code then concatenates the phrase starting with the first 2 date, followed by the last 2 date, and finally with ending. After printing, the user is most likely provided with the tweet's range of time. It would show the earliest and latest dates when the tweets were created or collected to let the user know the timeline of the data. A method call on a data frame called tweets is likely to be taking place in Python's pandas library. A data frame's info method displays a concise summary. It will display information such as the number of entries, the number of non-null values in each column, the type of the column, and the amount of memory used. Step by step, when tweets info is called, the method goes through the columns of the data frame tweets and gathers information about each column, including its name, its data type, how many non-null values it has, and then it outputs this information in a human-readable form, typically to the console. It's useful for getting a quick overview of the data frame and determining what kind of data cleaning is needed. Using this code, you can search for stock news scrolls using a function that takes 2 input parameters: a stock ticker symbol, a short abbreviation used to uniquely identify publicly traded shares on a particular market, and a list of URL templates. For each URL template in the list, a search URL is created based on the ticker symbol. This code fetches the content of the web page using a GET request for each formatted search URL. It uses Beautiful Soup, a Python library for parsing HTML and XML files, to parse the web page content into an easy-to-work-with format. This function searches through the content for all tags starting with a, which typically indicate hyperlinks. Next, it gathers these tags' href attributes, which indicate the hyperlinks, targets the curls they point to. An empty string is added to the list instead of the URL if the tag is missing in href attribute. The function returns a list of href values, which are curls pointing to news related to the ticker. One could use this list, for example, to analyze news about a specific stock or to gather related news curls. This code defines a function called strip unwanted curls that takes 2 arguments: curls, which is expected to be a list of curls uniform resource locators in string format, and exclude list, which is expected to be a list of strings that should not be present in any URL to be included in the final result. As soon as the function is invoked, an empty list named val is created. Afterwards, the list of curls is iterated over, checks whether each URL begins with chups, and if it does not contain any of the exclusion words listed in the exclude list. A regular expression is used to find a match for an HTTPS URL if both conditions are met. To include only the base URL without parameters, it breaks this match at the ampersand character. The first segment from that split is added to the val list. It converts the curls into sets and then returns them as lists after processing all curls. This list only contains HTTPS curls with no excluded words. Code defines a function named publishDate that takes a list of curls web addresses as input. It then creates an empty list called publishDate to store the dates at which the content of each URL was published. The function calls another function findDateURL to find the publication date for each URL that is provided in the input list, and then converts the return date to a string before adding it to this list. If an error occurs while trying to find the date for any URL, perhaps because the publication date can't be found or the URL is invalid or any issue with the findDate function, the code catches the exception and adds the string none to the publishDate list to indicate no date could be retrieved for that URL. Once all curls in the input list have been processed, this function returns the list of publishing dates or none placeholders when dates cannot be determined. With this code, you can gather news articles data for a list of stock tickers and their curls. This data is returned as a pandas data frame, a type of table used in Python to handle and analyze data. getNewsData takes two arguments: ticker list, a list of both stock ticker symbols and their associated curls, clean curls. The data about each article is stored in an empty list named articles info. It checks each URL associated with each ticker in the ticker list. In each URL, it tries to 1. To store information about the article. Create a dictionary article dit. The second principle, you need to use the article class probably from the newspaper package to download the article's content. The third step, add the URL and ticker symbol of the article to the dictionary. The fourth point, try to extract and store the text and title of the article using text parsing methods. If an error occurs during the parsing e.g., an article exception, it catches the error and sets the text and title fields to null and not a number, which is used here to denote missing values. Fifth, process the extracted text using natural language processing and NLP techniques. This may be required for additional features not specified in the code snippet. Then, it adds each article's information to the article's info list after parsing all the curls. In order to facilitate analysis, the function converts the list of dictionaries into a data frame, which is well organized. The final step is to return the data frame containing information about the news articles. A Python package used for parsing HTML and XML documents, Beautiful Soup 4 abbreviated as BS4, is installed using the given instruction. Using the exclamation mark syntax, this command can be executed using a Jupyter notebook or an environment that uses the pip package manager. As soon as the command is run, pip will download and install the BS4 package from py or another configured package source. BS4 will be available as soon as it is installed in the Python environment, allowing it to extract data from web pages. You've shared code that creates a dictionary with key value pairs that represent stock tickers and curls associated with news about that stock. Various banking-related stocks are listed as ticker symbols at the beginning of the document. A single item list containing a Google search URL template is also defined. By means of a dictionary comprehension, the code then constructs a dictionary called rawcurls, a comprehension that iterates over each stock ticker in the data stored in ticker list. The script calls a function called search for stocks news curls for each ticker, passing it the ticker and curls. It is unclear what the implementation details of this function are, but from the function's name and parameters, it appears that the function formats the Google search URL with the stock ticker to search for news related to that ticker and returns a list of curls from Google News search results. As a result, rawcurls is filled with keys representing each stock ticker, and the corresponding values are the results from the search for stocks news curls function, presumably lists of news curls for each ticker. It analyzes data from curls associated with various stock tickers. In the beginning, it starts with an empty list called links. Afterward, it iterates over a list of stock tickers, called ticker list. Code execution for each ticker symbol in this list involves two main actions. 1. For each ticker, it outputs a message showing how many curls are present. A dictionary presumably called rawcurls is used to attain this, where the key is the ticker symbol, and the value is the curls corresponding to that ticker. A printout is provided for the length of this list for a specific ticker. The second, once the message is received, the code loops through each URL in the list corresponding to the current ticker in the rawcurls dictionary. Whenever a URL is found, it is added to the list previously initialized under links. After processing all tickers in ticker list, the code prints the total count of curls that have been collected in the links list. A total of rawcurls extracted from all tickers is shown here. This snippet is creating a dictionary called cleaned curls that will store a collection of values associated with various tickers, which are presumably some sort of identifiers. The dictionary is populated by using a dictionary comprehension, which is an efficient way to build a dictionary from an iterable, in this case, an index. Each time a ticker appears in ticker list, the code calls the function strip unwanted curls with two arguments: rawcurl sticker and exclude list. Rawcurl sticker is a collection of curls associated with the current ticker. The strip unwanted curls function will process this collection, removing any curls that should be excluded according to the exclude list. As an excluded list, the exclude list contains specific keywords, maps, policies, preferences, accounts, support, which are likely substrings used to identify curls not included in the cleaned curls dictionary. As a result, for each ticker in ticker list, the cleaned curls dictionary will have an entry for the ticker containing the filtered list of curls only containing the unwanted substrings. The code seems to be part of a larger code that processes curls associated with different financial tickers useful for identifying stocks and other securities. During this iteration, the code loops through each ticker in the list. First, it prints a message stating the number of curls associated with each ticker. The loop then iterates over the cleaned curls associated with the current ticker, adding each URL to the links list, which begins empty. It prints a message displaying the total number of cleaned curls collected in the links list after collecting all curls from all tickers in ticker list. This code snippet creates a dictionary named articles publish date. In order to form the dictionary, a dictionary comprehension iterates over a list called ticker list. For each ticker in ticker list, the code calls a function publish date with an argument that seems to be a cleaned URL, which is retrieved from a dictionary cleaned curls using the current ticker as the key. In this function call, a publish date is returned, which is stored in the articles publish date dictionary, with the ticker being the key. Basically, the code looks up the associated URL for each ticker, and then processes it using the publish date function. This final dictionary will be output or stored in the same article's publish date variable. A code snippet uses publication dates to count how many valid publication dates exist for each item in a list, presumably stock tickers. In the future, the code could be part of a larger system for counting and sorting through article publication dates associated with various stock tickers. As a general guide, the procedure is as follows: 1. As shown in the snippet provided, the list appears to be unused. The second is, it iterates over a list named ticker list, which contains different stock tickers. Assume the following: this script initializes a count variable for each ticker. The fourth point, in the next step, it loops through a collection of publication dates stored in a dictionary or similar data structure named articles publish date. Moreover, this code checks if the value of each publication date is not equal to none within the nested loop. In the case of an encounter with a valid date, the count variable is incremented by 1. In addition to printing out the ticker along with the number of valid publication dates for each ticker, the code also prints out all of the valid publication dates for each ticker. Lastly, there seems to be a bug: the code happens linked to the list of dates, which isn't correct. The variable was likely intended to add a date or link from article's publish date. Due to the insufficient definition of link in the code snippet, this part may not function correctly. Using this code, you will be able to identify and count the number of publication dates associated with each stock ticker in ticker list. However, it seems that the portion intended to collect and store these dates is incorrect or incomplete. As this code snippet loops through the ticker list, for each ticker referred to as the ticker, it performs the following steps. 1. Two things are printed to the console: the current indicator from the indicator list, and the number of resources associated with the indicator in the article's publish date dictionary. For each ticker, this tells you how many publication dates are recorded, presumably for articles. The second, for each ticker, the code iterates over the publication date stored in the article's publish date dictionary. Lastly, iterating through this code, one item will be added to a list called dates called link. This code snippet seems to be missing a link definition, as it isn't defined within the visible scope of the loop, and it hadn't been updated there either. This should likely append date or some value derived from the current publication date or URL associated with date, not link. Basically, the code reports the number of publication dates for each ticker in a list and gathers all the publication dates or related links into one list called dates. It seems there may be a line or several lines of code missing or an error that needs to be corrected, because there is an undefined variable link. Apparently, this line calls a function named getNewsData receiving two arguments: ticker list and clean curls. A ticker list and a cleaned curls list are expected to contain a list of stock market ticker symbols for which news data is needed. The function getNewsData is expected to retrieve or generate a dataset containing news information pertaining to the specified ticker symbols, and then store this information in a variable news data. This function returns news data that may include recent articles, headlines, sentiment analysis, or other information related to the tickers that are listed, depending on the implementation of its content. Using the code snippet, you can do the following. 1. Initially, it creates an empty list named dates, assist not allowed. After that, iterates over a list called ticker list, which appears to contain ticker symbols for stocks, financial instruments, or other items. The third point, further, it iterates over a list of publication dates associated with each ticker symbol. It is retrieved from a dictionary or similar data structure called articles publish dates, where the key is the ticker and the value is the list of publication dates. As a result, in this iteration, each publication date associated with the current ticker is added to the dates list. In addition, the cumulative publication dates are then assigned to a key timestamp in a dictionary or a data frame, most likely a pandas data frame called news data. Essentially, the code aggregates all article publication dates from each ticker in each ticker list, and then records them in news data under timestamped. In certain circumstances, this may be part of the process of processing data for analysis, perhaps to correlate financial news with market movements. Using this code, which filters a dataset for records with none in the timestamp column, a dataset is removed. It's initializations of news data or datasets, possibly data frames in Python. If this is part of pandas, it checks if the timestamp value is not equal to the string none for each row in news data. We keep rows that meet the condition i.e., their timestamp is not none, and discard others. In this case, the filtered dataset is reassigned to the original variable news data, thus updating it to only contain relevant timestamps. The code above is part of the NLTK Natural Language Toolkit Python library, which provides libraries and codes for the symbolic and statistical natural language processing (NLP). This code will execute two specific actions. 1. The library first downloads the package punct. In this package, pre-trained models help tokenize sentences and texts. Basically, tokenization consists of separating a text into separate words, phrases, symbols, or other meaningful elements. Tokenizers such as punct divide a text into tokens that represent sentences. The second part, afterward, another package named stopwords is downloaded by the library. In natural language processing, stopwords are words that are filtered out because they do not contribute much meaning to sentences. Typical examples are the is and in. Stopwords included in the list are those that NLTK deems stopwords across various languages. In Python, these steps are generally part of the initial setup of natural language processing, as they provide the basic resources for text analysis. The given code snippet manipulates a column called timestamp in a dataset and data frame named news data. A function is applied to each entry in the timestamp column, which consists of date strings, by transforming each date string into a datatime object. The function handling dates and times in Python. It starts by extracting the year, month, and day components from each date string in the timestamp column. In a zero-based index, the year is the first 4 characters, the month is the 5th and 6th characters, and the day is the 8th character. In order to construct a new datatime object, the sliced string components are converted to integers and passed as arguments to the datatime constructor. To summarize, this line of code converts the string representation of dates in the timestamp column of news data into datatime objects, making it easier to perform date and time operations later. In the code, a function named timestamp adjuster takes 3 arguments: timestamp, start, and delta. It adjusts the timestamp provided based on certain conditions. It is, if the timestamp is between 9:15 a.m. and 3:15 p.m. of the same day. It adjusts the timestamp by rounding it up to the nearest interval specified by the delta, starting counting from start. As an example, timestamp set after 3:15 p.m. but before midnight, or set to 9:15 a.m. the following morning. Lastly, in any other case before 9:15 a.m., it sets the timestamp to that day's 9:15 a.m. A modified timestamp is returned after the function has adjusted based on these conditions. Within a data frame called news data, this code operates on a column called timestamp. Steps 1 and 2 are executed sequentially. 1. A timestamp in the timestamp column is reformatted in the first line. It uses the datatime striptime method to reparse each timestamp into a standard datatime object based on the specific format %y %s, which includes the year, month, day, hour, minute, and second. The second paragraph. The second line then adjusts each timestamp using a custom function called timestamp adjuster, which appears to be designed to manipulate the timestamp in some way based on additional parameters, specifically starting from a certain date datatime 2021, 1/0/15, and possibly by a certain time interval given by time delta Vorstone. The code processes timestamps to ensure they are in a consistent datatime format, and then applies a custom adjustment to each timestamp. In the code snippet you have provided, an operation called data cleaning is performed on a data frame named news data. The function removes all rows from the data frame that contain missing values nonnies in the text column. The dropna method is used for this purpose with the subset parameter specifying that only the text column should be considered when looking for missing values. Using the axis 0 argument indicates that rows not columns should be dropped. Lastly, the inPlaceTrue argument means that the operation will modify the news data dataframe directly, without the need to assign the result to a new variable. Thus, after this code runs, news data will cease to contain data with missing text values. Using this code snippet, we are going to target the text column in the dataset, most likely a pandas data frame named news data. This ensures that each entry in the text column is treated as a string text. A function is applied to every element in the text column, which uses the stir function to convert each element into a string. The apply function is a way to perform an operation across all elements in a column, and the lambda extracts is a quick, anonymous function that takes an element x each entry in the text column and applies the stir function to convert it to a string, if it isn't one already, in order to ensure all of the contents of the text column were string types. The result of this operation is assigned back to it. It is reindexing a dataset called news data. By doing this, the dataset's indices will be reset to a continuous range of integers from 0 to 1 less than the dataset's length. In order to maintain a consistent and sequential index, this is usually done after rows are added, removed, or shuffled within the dataset. It appears that the code you posted is part of a Python code that uses the pandas library to manipulate and analyze data. Suppose the news data consists of a pandas data frame, which is a two-dimensional labeled data structure with columns that could have different types. The head method is a built-in function in pandas that, when called on a data frame like news data, returns the first few rows of the data frame. Defaulting to 5 rows, it serves as an easy way to see the column names and the type of information stored in each column. A user can plan further data analysis tasks by understanding the structure and content of the data they are working with. The code below uses the first and last date function to extract the first and last dates from a dataset called news data. It takes 2 values as input and returns 2 values to be stored in variables firstNi and lastNi. The first and last values in these variables are presumably based on the date retrieved from the dataset called news data. This code extracts and assigns the dates, and prints a message that specifies which one is the beginning starting and which one is the ending, followed by the respective dates converted to strings. As a result of the new line character, the dates are presented on separate lines. I viewed the code as a simple utility that provides a quick glance at the times covered by the data in news data. Using this code, you can download historical stock data for a list of stock tickers within a specified time range and date range. Among the parameters of this function or list of stock tickers, a start date, an end date, a period which is likely to specify the duration for which data is required, and a resolution which specifies the time interval. In the next step of the function, all the tickers in the list are combined into an empty data frame. A loop is executed over the ticker list using the index to access each ticker. A new stock data set is downloaded each time by calling zef. Download in the eFinance module. Using this function, the data is adjusted for splits and dividends auto-adjust truth. The period and interval are set based on the function parameters, and the data is placed in a temporary data frame. By assigning the index of the temporary data frame which contains the date time information, it adds a timestamp column and also adds a symbol column. After that, this temporary data frame is appended to the primary stock's data frame. As soon as the loop is completed, a data frame called stocks data receives historic data for each ticker. In the loop, hapsbit clicks didn't16 there is a mistake, it should be ticker listic instead of ticker listic 1. Otherwise our code will be using a wrong index for accessing the ticker list. There is a code snippet in the snippet that appears to be part of a script for retrieving market data. In the first list, stocks ticker list, there are strings representing the ticker symbols of various Indian banks and banking indices listed on the stock exchange, e.g., Indian banks and banking indices on the National Stock Exchange of India. In addition, for the start and end, the minimum between first T and first NI are calculated separately. A user may use these variables to specify the start and end of a time frame for which he wants stock data to be returned, with the variables T and NI possibly denoting two different sources of date information. The period variable is set to quant, which suggests that the data should be collected on a daily basis, and the resolution variable is assigned quant, indicating that the data points should be at an hourly resolution. Finally, a function called getStocksData is invoked with the ticker list, start and end times, resolution, and period, based on the parameters specified. This function will fetch and store stock market data in the variable stocks data. You can then use this data for various analyses, such as tracking performance, historical comparisons, or supplying to a trading algorithm. As described above, this command isn't part of code, rather, it's a command line instruction for installing the Tweepy library in Python. Whenever it is started, it uses the pip package manager to download and install the Tweepy package from the Python package index py or another environment configured repository. Twitter Hippus or easily accessed with Tweepy, an open-source Python library. When this command is run successfully, a developer can utilize the functions and classes provided by Tweepy in their Python code for automating tasks like tweeting, accessing Twitter data, and managing tweets. In this code snippet, the index of a data structure called stocks data is reassigned, which is likely an index in a pandas data frame because index is a common attribute used in pandas. The index will begin at 1 instead of 0 and continue sequentially for as long as stock data contains elements. Typically, this is achieved by creating a new range object that starts at 1 and goes up to 1 longer than stock data so that every row gets a new index number. As a result, row labels will no longer be indexed by 0, but by 1. A data frame named stocks data that contains a column timestamp contains datatime objects in the code provided. In sequence, it performs the following 3 operations. 1. This operation creates a new column named date in the stocks data frame. The entries in this column were generated by extracting only the date portion from the corresponding datatime object in the timestamp column. Here are 2. In the same data frame, a second column is added named time. A similar step is performed, except that this time only the time portion of the datatime object is extracted from the column timestamp. 3. The timestamp column itself is modified as well. This column first converts the datatime objects into strings with specific formats %y parent and parent %h parent parent s, then parses them back into datatime objects. In this step, the timestamp data will be reformatted without changing the underlying date and time. This code will create 2 new columns, date and time, as well as a reformatted timestamp column, providing both date and time components for analysis or processing. The code provides a mapping between stock names and ticker symbols. This code first creates a dictionary called stocks symbol map, which holds different bank names e.g., NIFT, YBNK, SBIN, etc. They are also identified by their stock ticker symbols such as NSEBNK, SBIN and S, etc. It is a value. Trading and data analysis commonly use ticker symbols to translate stocks from their common names. As a next step, the code generates a reverse mapping dictionary, symbol stocks map, inverting the key value pairs in stocks symbol map. Symbols for stock tickers become keys and bank names become values. As a last step, the code appears to create or update a column named ticker in a data frame named stocks data. The symbol column of the data frame is mapped to the symbol stocks map so that each symbol in the symbol column corresponds to the name of the bank. A data frame is done by finding and applying the names of the banks from the symbol column based on the symbols in symbol stocks map. Stocks data head usually appears in Python codes where stocks data is a data frame object likely from the pandas library, a popular Python data manipulation library. It calls the head method of the data frame named stock data. The head method returns the first 5 rows of the data frame when it is called without any arguments. This is useful when you want a quick understanding of the data structure, including column names and the types of data each column contains, without having to display the entire dataset. For example, if stock prices are contained in stock data, head would display the first 5 records in the dataset, such as the date, opening price, closing price, high, low, and volume traded. It is commonly used when analyzing exploratory data to verify loading and to identify the structure of datasets. The code snippet is operating on a variable called stocks data, which is assumed to be a data frame, a type of data structure in the pandas Python library used to handle tabular data. A subset of columns from the stock data frame is being selected. This code creates a new data frame that contains only the columns open, volume, ticker, and timestamp. This data frame will have these columns listed in order. Usually this is done to work with specific columns from a larger dataset. In this snippet of code, we iterate over a collection named stocks data containing a key named timestamp, starting from the first element index 1 and continuing up to the last element. The code performs a transformation on the timestamp for every element in the list. The code, each time iterates, stores the current timestamp in a variable called temp, and then creates a new datetime object based on temp. Then it replaces the original timestamp at index I with this new datetime object. In essence, the code converts every timestamp in stock data timestamp to a specific datetime format without accounting for local time zones or microskins. In this code, the value in the ticker column is filtered to only include rows with the string NIFTYBANK in the ticker column. By doing so, it creates a subset of stock data that contains only information related to NIFTYBANK. In data analysis, this can be used to focus on a particular segment. Each row in the ticker column is checked and included in the output if the condition NIFTYBANK is true. By removing rows that do not meet the criteria, a new data frame is formed. Timestamp settings in a data frame called tweets are adjusted by the code snippet. A timestamp value x is passed to the function timestamp adjuster along with two additional arguments: a starting date time 2021-1015 and a time delta object representing an hour difference for each entry in this column. The snippet does not define the timestamp adjuster function, but it likely aligns or shifts the original timestamps based on the start date time and time delta given. After this adjustment, the result is reassigned back to the timestamp column of the tweets data frame. During this operation, each row is updated with the adjusted times, which are then shown in the timestamp column. The code snippet above represents a dataset, probably a data frame, a type of data structure provided by Python's pandas library. Specifically, the code accesses and reassigns to tweets a subset of the columns originally assigned to them, namely the columns ticker, title, and timestamp. Any other columns that were previously part of the data frame will no longer appear in tweets following this operation. The data is filtered so that only the most pertinent information is presented, or the dataset is prepared for further processing that only requires those columns. It modifies the columns of the tweets data frame. It replaces the current column names with new ones, with the first column becoming ticker, the second into text summary, and the third into timestamp. Data renaming is often used to make data more understandable or to standardize column names, especially if the original names are not descriptive or if you want to adhere to a certain naming convention. It's a simple step in data preprocessing before analyzing or manipulating it. By using pip, we install a Python package named TitleDate. This package counts published dates for web pages and online documents. You run this command to search for the TitleDate package in the Python package index py. Download it and install it. By installing TitleDate, you can use its functionalities to detect and extract the publication date from web-based content within Python scripts. A machine learning library is used to initialize the text summarization pipeline you provided. Throughout this context, pipeline may refer to a feature of the Transformers library by Hugging Face, which is a popular toolkit for natural language processing. With the argument summarization, the pipeline function creates a pre-configured pipeline for the specific task of summarizing text. In this summarization pipeline, a pre-trained model and tokenizer are loaded into the pipeline to condense the content of longer texts into a shorter summary while retaining the main points. Using just this line of code, a summarizer can automatically generate summaries of text inputs. Summarizing text is as simple as passing text to the summarizer. With the code snippet provided, you can create a summary of texts within some dataset with the key text, which likely contains news articles. Listed below are the functions performed by the code 1. An empty list called text summary is initialized, which will contain summaries of the individual texts. The second point, in the next step, a loop iterates over each piece of text in news data text. Loops are done from 0 to 1 the index of the first text and 1 to the last the index of the last text. Lastly, inside the loop, for each iteration, it calls a function called summarizer on just the first 512 characters of the current text, news data text to 512, to create a concise version of the original text. The summarizer probably employs some form of natural language processing. Forging summary functions are given specific instructions about the length of the summary they should produce. They must not exceed 50 characters, max length 50, and should be at least 25 characters. It is also instructed not to sample the output randomly. Do sample false, so it will generate the summary in a deterministic fashion. In addition, a list of dictionaries containing a summary text field is returned by the summarizer function, and the field is extracted and stored in the variable summary. 66. A summary of the text is added to the text summary list. A list of condensed versions of the texts will be generated by the summarizer based on the length constraints specified in the text. The result is basically a collection of summaries for each text in the news data text dataset. As you can see, the code snippet you provided performs an assignment operation in the context of data manipulation in what appears to be a pandas data frame in Python based on its structure. This data frame contains a column labeled text summary named news data. A value is assigned to each row in the text summary column of the news data file by the code. Data frame text summary column is filled with the contents of text summary in this operation. As an example, a summary of a news article could be appended to a structured dataset containing news articles to be analyzed further or stored for future reference. All rows in the data frame were affected by the operation, which sets the value for text summary to the same value. Most likely the code is using the pandas library to manipulate data in a Python environment. In the first step, it selects 3 columns from the news data, namely ticker, text summary, and timestamp. As soon as these columns are selected, another data frame called tweets is appended to the bottom of the selected data frame. The result is a single data frame called news and tweets that combines the information from the specified columns of news data with the entirety of the tweets data frame. Consolidating related data from different sources into one dataset can then be used for analysis or further processing. News and tweets is a pandas data frame that needs to be reindexed. In particular, it changes the index of the data frame to an integer range where the starting index is 0 and the ending index is 1 shorter than the length of the column text summary. The data frame's indices are then arranged in a sequence of consecutive whole numbers, which is useful after filtering or concatenating data to alter the order or number of rows. In Python, the line you referenced is a method call that typically operates on a data structure, such as a data frame, to retrieve the first few rows of the data frame called news and tweets. Use the head method. Data frame's head method will return the first 5 rows by default if no argument is provided. If none is provided, in this method, we can quickly verify that the data has been loaded correctly into the data frame or inspect the beginning of a large dataset. As a result, it provides a convenient snapshot of the structure and content of the top part of the dataset without displaying the entire dataset, which could be large. This code snippet is taking advantage of the stopwords from the natural language toolkit NLT to retrieve a collection of common English stopwords, words that are filtered out when processing natural language data because they are deemed to be of little value to the understanding of the text, such as the is and in. The variable stop is being assigned this list of stopwords. The code retrieves the first 5 stopwords from the English stopword list by using Python slice notation stop5. In slice notation, the index of position 5 is included as well as all elements up to, but not including, the beginning of the list. Using only the first 5 stopwords of the original list, a smaller list is generated. The code snippet contains instructions for removing certain unwanted words typically called stopwords from a column within a data frame, assuming news and tweets is the column. The text summary column of this data frame contains text data. Here are the steps that the code performs for each entry in the text summary column. 1. Tokens are created by splitting the text into individual words. The second, any word present in the stop list, which is assumed to be a predefined list of stop words, is excluded. The third is, in the end, the remaining words are rejoined back into a single string with spaces between them. In addition, afterwards, we place the processed string the summary without stop words back into the text summary column of the data frame. This filtering and rejoining operation is applied to every item in the text summary column using the lambda expression, thus cleaning the text data by removing all unwanted stop words. When using an open source data manipulation library called pandas, you typically use this Python instruction. According to the code, there is a data frame object named news and tweets. Often used as a representation of a table of data, a data frame is a two-dimensional labeled data structure. An instance of data frame is called using the head method. The default return value for this method is the 5 first rows of the data frame. The purpose of this is to help you quickly see how the data looks without displaying the entire table. It is often one of the first steps a data analyst takes after loading data to verify that the data has been read correctly and to determine its content and structure. This function will return the number of rows from the top of the data frame if the parentheses are present. The default value is 5, however, with no arguments. Specifically, this code snippet initializes Finbert, developed by Process AI for analyzing financial sentiment, a machine learning model that has already been pre-trained. It loads the Finbert model using the auto model for sequence classification from pre-trained method. By using this method, you are able to retrieve a set of model architectures and weights that have already been trained on financial text data. Tokenizers for the same Finbert model are then retrieved using auto tokenizer from pre-trained. When a tokenizer is employed, raw text is converted into a format the model can understand, essentially parsing sentences into tokens or words that have been seen by the model in the past. In the end, these two components form a sentiment analysis pipeline. This is a high-level utility that simplifies the process of converting raw text into classifications. As a result, the classifier created can be used to predict the sentiment in financial texts, categorizing them as positive, negative, or neutral based on their content. The Python library Sentinipiece can be installed with the command pip install Sentinipiece. Running it in a Jupyter notebook or terminal with Python installed is required. First, the command begins with the pip package manager, then runs the install command, which initiates the installation of the package. In this case, the package to be installed is called Sentinipiece. Upon execution, pip will connect to the Python package index py or another configured repository, download the Sentinipiece package and all its dependencies and install them. It is commonly used to indicate that the command is to be executed in a notebook-like environment such as Jupyter, and that it should be interpreted by the system shell instead of the notebook's language interpreter such as Python. This code manipulates a pandas data frame called news and tweets, which contains a column named text summary. Using the classifier function, it adds columns related to the sentiment of the text in the text summary. Each element in the text summary column is given a sentiment column as the result of applying the classifier function. An output from this function includes at least one dictionary containing keys, label, and score, which represent the sentiment labels such as positive, neutral, or negative, and confident score associated with it. As the code creates 2 more columns in the data frame based on the newly created sentiment column, it uses the newly created sentiment column. The first dictionary in the sentiment list is named label and it contains the values extracted from the first dictionary. A second is named score, which extracts the score value from that dictionary. This method chaining allows the data frame to be extended step by step with these additional columns that hold sentiment analysis results for each summary text. Code like news and tweets, head likely calls a data frame object named news and tweets. This method is used to manipulate and analyze data using Python's pandas library. A call to this method returns the first few rows of the data frame news and tweets. As a default, head returns the first 5 rows, but you can optionally pass in an integer to change the number of rows returned. E.g., headn would return the first 10 rows. A data frame can be quickly checked for structure and content to understand the information it contains, without needing to display the entire dataset, which may be large. In this code snippet, we iterate through the timestamps of news and tweets stored in a data structure called news and tweets under the key timestamp. For each element in the timestamp list, which can be assumed to contain datatime objects, the code extracts the year, month, day, hour, minute, and second components of the timestamp and constructs a new datatime object with these components. After being created, the datatime object is used to replace the previous timestamp in news and tweets timestamp. The loop runs for the entire length of the timestamp list. So by the end of the process, all the original timestamps in the list are updated to be datatime objects, potentially removing any additional information such as time zone information that might have originally been present. By using this command, we will remove a column labeled sentiment from a data frame named news and tweets. By using the drop method, we remove the sentiment column. This parameter indicates that the operation is to be performed on a column, not a row. Inputting in playTrue indicates that the change will only affect the original data frame news and tweets, rather than creating a new one without the column. In the future, this command will not be necessary. In your code, you have probably included a line of code that is likely part of a larger Python code involving data manipulation, which may make use of the pandas library to handle data frames. Line 202 modifies the column headers of a data frame named news and tweets. This will change the columns names in the following order: ticker, text summary, timestamp, sentiment, and sentiment score. This data frame has columns named ticker, text summary, and image summary, with each corresponding to a column within the data frame. A column is typically clarified, or the column names are standardized in this operation for further analysis or processing. Code snippet provides iterates through a collection titled news and tweets that appears to contain information about news and tweets, particularly their sentiment and sentiment score. In the loop, the sentiment type and score of each item are examined. The sentiment of an item is updated to buy when its score is 0, 6 or higher. It's updated to sell if the sentiment is negative with a score of 0, 6 or higher. The sentiment is set to none in all other cases when either the sentiment is not positive or negative, or when the sentiment score is below 0, 6. A sentiment score threshold is used to categorize sentiments into actionable choices, buy or sell, or neutral choice is none. On the basis of sentiment scores from news and tweets, this code determines how many shares to buy. To begin, the budget is set to 10, 0 per share, and quantity column in news and tweets data frame is initialized with zeros for each ticker mentioned. After that, the code iterates over each sentiment score associated with a ticker and timestamp. The code checks the sentiment score during each iteration. The number of shares to buy with the full budget is calculated by dividing the budget by the opening price of the stock on that day if the score is very positive, greater than or equal to 0. 9. Prior to calculating the quantity, the budget is decreased by 2, 0 for each step down in the range that the sentiment score is below 0. 9. Whenever the score is below 0, 6 or an error occurs during calculation, the quantity is set to 0. A rounding function ensures whole number quantities and handles exceptions by setting the quantity to 0 if an issue arises. Resulting quantities of shares to buy are stored back in the quantity column of the news and tweets data frame. This instruction implies a method call on the pandas data frame object news and tweets. Head, it retrieves the first few rows of the data frame, usually the top 5. A user who calls this method is likely interested in taking a quick look at the content of the database found within news and tweets. As a result, the user can see the columns and values of the first few rows, allowing them to know what kind of data is stored and how it's organized. Data frames called news and tweets are being modified in the code. An element in the timestamp column in the data frame will be applied a function. This lambda function converts each timestamp entry into a datatime object using the pandas library scheme. To datatime method, code snippet converts all string timestamps in the timestamp column into a standardized datatime format that makes data analysis and manipulation easier. Listed above is a Python code snippet that modifies a data frame named stocks data, which is then referenced by the variable saint. The code below converts the entries in the timestamp column of the stocks data frame from their current format into proper datatime objects recognized by pandas. A popular Python data manipulation library, it uses the apply method with a lambda function that calls to datatimics, where x is each individual entry in the timestamp column. Using the lambda function, the conversion to datatime is applied to each element in the timestamp column, thereby updating the data frame so that the timestamp column no longer contains strings or other formats, but instead contains datatime objects. Afterwards, it will be easier to use the data for datatime related operations. In a Python environment, this command is used to install specific versions of 3 libraries: Torch, TorqueVision, and TorqueAudio. They're commonly used for machine learning tasks, especially neural networks, and are part of PyTorch. It performs the following tasks. 1. Installing Python packages is done through the package installer pip. The second is, specifically, it specifies the versions of the following packages to be installed: Torch version 1, 9, 0, TorqueVision version 0, 10, 0, and TorqueAudio version 0. 9.0. It indicates that these packages are compiled with support for NVIDIA's parallel computing platform encode model, CUD 11.1, to make computations faster. This version of CUD utilizes the GPU. 3.2. This option points pip to the URL where these packages can be found with the F flag. To download PTorch files, it instructs pip to look at the torch stable page on the PTorch official website. This command sets up the Python environment with the PTorch packages required to facilitate GPU-accelerated machine learning. It merges two pandas data frames, st and int, using an as of merge, which means it matches on keys closest to each other instead of matching exactly. Data frames are sorted first according to the timestamp column, which is required for this merge. Merging is performed on the field timestamp, where the merge finds the row in int with the closest timestamp that is either equal or forward in time because the direction parameter is set to forward. Additionally, the merge only considers rows where the ticker values are the same in both data frames. The resulting data frame diff consists of rows combining information from both st and int where the ticker is the same, and the timestamp from int is the nearest future timestamp to the timestamp in st. In Python with the pandas library, the snippet diff head is typically used to see the first few rows of a data frame named diff. Upon execution, the top 5 rows are returned. A quick sense of data structure can be obtained by using this function, along with the names of columns and the types of data that can be found in them. It's commonly used after loading a dataset to verify that it has been read correctly. It is possible to specify the number and inside the parentheses to display more or fewer rows, e.g., diff headn. This code demonstrates a process for manipulating and visualizing financial data from a data frame named diff. As a first step, it extracts a subset of the data frame using the columns timestamp, open, quantity, ticker, and sentiment. In this loop, it starts from the second row, and whenever it finds a row where the ticker is not an IFTYBANK, it replaces the open value of that row with the previous row's value. Using matplotlib, the code creates a plot using the modified data frame. Open prices are plotted over timestamp with small circular markers. Additionally, it adds green upward pointing triangles at points where the sentiment is buy and red downward pointing triangles at points where the sentiment is sell, highlighting buy and sell moments on the graph, limits on the y-axis, price axis, or just the range of open values for an IFTYBANK. Finally, the plot is labeled with timestamp on the x-axis and rupees on the y-axis, with the title and IFTYBANK as the label. The code is generating a series of plots, specifically 12, as indicated by the nrows 12 of stock data for different tickers' stock symbols from a data frame diffs. A ticker in the ticker list is processed the following way, except for the last one. Temp data frame with timestamp, open, quantity, ticker, and sentiment columns is created. In addition, it iterates through the timestamp column of temp end. When a row doesn't match the current ticker tilt, the open price is replaced with the open price from the previous row. The third point, blue, is used for the blue line plot of open prices against timestamp on the TTH subplot out of 12. As mentioned above, for the current ticker, it overlays green upward pointing triangle markers at points where sentiment is buy. The fifth point, additionally, it overlays red downward pointing triangles for tickers whose sentiment is sell. In paragraph 6, for the current ticker, the y-axis limits are set to the minimum and maximum open prices. The seventh, each subplot is titled according to the current ticker, with labels for the x-axis timestamp and y-axis rupees. In chapter 8, for the plot layout, tight layout is called. A single figure shows 12 subplots, each showing price trends for a different ticker and buy-sell sentiment. The y-axis ranges for each subplot are tailored and titled accordingly. A simulated trading portfolio is managed by this code using sentiment analysis and certain constraints. Initializing this system, it sets up 2 dictionaries representing a portfolio and a bank account for each ticker symbol listed ticker list. Data frame diff contains the following information about trades: timestamps, sentiment, buy-sell.